Bismillahirrahmanirrahim. My name is Kainat Abasi. My roll number is 16TE83. This is the week 11 lecture number 2 of digital signal processing. In this lecture we will discuss about FIR window method. Why we use FIR window method? To remove undesirable jigs oscillation in pass and stop band of FIR filters. What is jigs effect? Jigs effect occur when we have sharp transitions. Solution to jigs effect is window method, and the formula we use for applying the window method is H W of n is equal to H of n multiplied with W of n. W of n is Windows function. There are 5 types of windows: rectangular window, triangular window, Hamming window, Henning window, and Blackman window. And their formulas are: for rectangular we have W of n is equal to 1. For triangular we have W of n is equal to 1 minus mod of n over m. Similarly, for Hamming we have 0.5 plus 0.5 cos of n pi by n, and for Henning we have 0.54 plus 0.46 cos of n pi by m. And for Blackman 0.42 plus 0.5 cos of n pi by m plus 0.8 cos of 2 n pi by n, where n varies from minus m to m, and m is calculated using number of taps is equal to 2m plus 1. Let's consider an example of Hamming window. We have 5 tap low pass filter, and we want to find the response for H of 0, H of 1, H of 2, similarly for H of minus 2 and minus 1. And we are given, we know that for low pass filter H of 0 is equal to omega c by pi, and H of n is equal to sine of omega c n divided by pi n. Here omega c is 0.2 pi radians. Sampling frequency is 8000 Hz. 2m plus 1 is equal to 5, that is equal to number of taps. We can calculate m, that is equal to 2, like 2m is equal to 5 minus 1, which is equal to 4, and 2m is equal to 4, and we will get m is equal to 2. Similarly, H of 1 is equal to H of minus 1 using symmetry, sine of 0.2 pi divided by pi, and here n is 1. We will get 0.187. You can verify using minus 1, we will get the same result. And for H of 2 and H of minus 2 we will get 0.151. So the impulse response H of n is given by 0.151, 0.187, this is index 0, and similarly this. Here we have sharp transitions. We want to reduce these sharp transitions, and we will apply the function of Hamming window. W of n is equal to 0.5 plus 0.5 cos of n pi by m. Here we will also follow the symmetry. You can verify by calculating for 2 and minus 2. I calculated for minus 2 and the value is 0. Similarly, for 1 and minus 1, the value comes out to be 0.5, and for 0 the value is 1. So write the impulse response H of n and the Windows response W of n. And we know that we will multiply these two and get Hamming window response, and the response is this. Here the transitions are smooth, cutoff transition is less. Each window has its own benefit, like for Henning and Hemming we have good roll off, and for Blackman we have good stop band attenuation. You can apply all other windows using the same method. Thank you very much.